So they've chosen to use 3/16 inch extra high strength guy wire, so that's a good move. It's maybe a little thinner than I would like, but they use the right kind of wire. At least it's the high strength. They've got a big grip installed on here, and it's not quite woven in properly. And then the guy isn't tensioned at all. It's very floppy. The actual rock bolt, they're using a boulder. This is a 3/4 inch bolt. That's a 7 inches in, and it has been drilled and epoxied. We found the epoxy on site. But it's a 1/4 inch come along, or a turnbuckle here. And it's braced tight to the rock. So any lateral force, you can see we're bending the actual buckle here. So that'll snap. Now it's gonna be pulling linearly mostly. But this probably needs to be beefed up quite a bit. On these big grip guy wire stays, the manufacturer, if you watch a YouTube video or do basic research, these are supposed to have a protective eyelet where it attaches. So it wants to be something like this. And that keeps it from getting a hard crimp on this end and weakening the wire and blowing out on this end. So this would have to be reinstalled, pulled off, and properly tensioned with a Chicago grip out here so we can tension the wire, get it the right length, and then insert the eyelet on the end of the big grip so you're not blowing out there. And then if we have to install a second set of guy wires, there's nowhere to drill another rock bolt in here. So I don't know where you're gonna put it. You can't attach it to the same piece because it'll blow through this in a heartbeat. And then I'm not sure where we're gonna drill it in. If we point at the tower, they've attached the big grip ends directly to 2 of the legs of the tower. And then you can see with the shackle they've attached to the bracing going up the side. Well, the bracing is the weakest part of the tower. And that's at an end joint. So that's relying on one weld to hold up that entire guy wire. So it's not distributing the force. Standard industry procedure is to use a triangle square around the triangle of the tower to distribute the force. So that needs to be installed before this is a workable system at all. The other thing of concern is these guy wires are not coming out perpendicular to the end legs. They're coming out at an angle. So any wind is going to put torsion on the tower, and towers aren't good under twisting strength. They're good vertically, and then the guy wires are meant to distribute that. But if you get wind, it's going to twist the tower against the wires, and that'll weaken the whole system. So that's another concern of mine. Again, we don't have ring eyes at the top, and they really should be held in there with hasps against it, so that if you ever have to change out the guy wires, which is part of regular maintenance of the tower, that you can actually do that. In this case, you couldn't change out the guy wire, so we'll have to readdress that here soon. This tower was, if it was engineered in the first place, it was only meant to go up 20 feet. We're taking it up to 40 at this point. And looking at the roan at the top, it's got a little ground damage, so it's a little bent. I don't think that's a really critical thing at this stage, but we'll see once we get up with an improvised safety system how it feels at the top. Anyhow, those are questions I have for you guys to try and figure out how we can address and make this a better system. The other thing I've seen is all 3 guy wires come into the tower at different angles. Some are up a hill, so they're real shallow. Some are down a hill, so they're real steep. And normally when we see tower engineering, they all come in very even, so they're keeping all the stresses on the tower at the same angle, so they can distribute amongst the 3 systems. So if you're pulling on a shorter cable because it's a higher length, you're going to put different tension on that than you are on the longer cable on the side next to it. Again, that's going to put different twisting forces on the tower. And my son's an engineer and he hates it, but any little thing that isn't the way it's engineered to be throws the whole calculation out of whack. So we're going to have to be careful about that as well. That's all I got for now. So we're trying to figure out how to make this as safe as we can, and hopefully bring in some guys who know more and can help it out on this.